in this type of computers of fifth generation, artificial intelligence is used. So like human have different sense organs, like they can touch, smell, see, hear, like that. Computers are also given this type of sensors. We are going to see a basic model of that kind of artificial intelligence also here. So you can see that in this picture there is one robot, a symbolic AI picture, that is artificial intelligence. So we all know that nowadays driverless car will be introduced at any time in near future. Same way, you might have heard about automatic surgery done by robots in medical science field. So in production also, in automobiles and other companies, this type of robots are being used. So actually, a robot is not which looks like a human being, but it can be any mechanical structure depending on the task that we are going to perform with that robot. Now in fifth generation computers, we are going ahead with this artificial intelligence afterwards, but let's discuss about some features of fifth generation computers. So fifth generation computers are having very high processing speed. It is user friendly, means with a minimum amount of knowledge you can work on it, and connectivity to network. A network of 4G or 5G speed can be connected with this type of computers. So processing speed here depends on what? CPU, that is central processing unit, and primary memory, that is RAM. So nowadays advanced CPUs are being introduced. For example, processors are i3, i5, i7, like that, and RAM of very high capacity, 18 or 16 GB, like that, is used in this type of computers. Now few examples are IBM, that is International Business Machine notebooks, Pentium PCs, and Param 1000. Param 1000 is a supercomputer built by India. Okay, these are fifth generation computers. Now let's understand this artificial intelligence by a video. So I'm going to show you a video of a simple structure of robot. Now see this. This is a small mechanical structure. Okay. Now there is one device which can be programmed, and with this device different sensors are attached, and depending on this program, these sensors read the input. This is a light sensor. So right now it is receiving normal light, and here I am holding a torch. So when sorry, when I am moving torch near to this sensor, then it is following that light. So let's see that. Now it is moving. That light is given to that sensor, so it is receiving more light, and then it is following that light. Now I have removed that. Now again, okay. So this way light sensor works. Okay, so you can guide it through light, otherwise it will move randomly. Now again, here are light sensor. This read lights you can see, and this is one obstacle. This is one obstacle. Okay, now it will read the light that is being reflected to it. So when it is far from any obstacle, then it is receiving very low amount of light. As soon as it comes near to an object or an obstacle, then light reflection will increase, and when it will increase up to some amount, then it will move back and take a turn. That is being programmed. Okay, so now you can see that now it is moving. Now light reflection, then it has turned out. Now light reflection. Okay, now there are two sensors here, and these two sensors, why we are using here two sensors, because when it will approach to an obstacle from this side, then this sensor will not detect that reflection. So two sensors are being used here. So now here in this structure there is one light, okay, and there are two surfaces. This is white, this is black. So on black surface we know that light reflection is minimum, and on white surface light reflects more. When the sensor will detect reflection more, then it will take turn to find out the place from where it gets minimum light reflection. So it will follow this black path. That is turning that on. Now see, it is following black path. Now this is new field to computers, and now see, I am breaking this here by putting a paper. Now see, now it is not getting that light reflection, so again it is finding that black path. See, now see, now it is moving forward again. Right reflection load you the white surface. Okay, now it is moving ahead. So that was topic of artificial intelligence. Now we are going to review what we have learned till now in this chapter. So this is summary of first, second, third, fourth, and fifth generation of computers. So what you should remember here, in first generation, what was used? Vacuum tube. They were bigger, slower, and less efficient. And example of this first generation computer were IBM Univac 1. Then second generation computers, vacuum tubes were replaced by transistors, and they were faster than first generation computers. And example is IBM 1620. In third generation computers, now circuits were used. So integrated generation computers were called mini computers. And example are IBM 360, PDP 8, and 11. Then comes fourth generation computer. Now integrated circuits, more circuits were integrated on that chip, and it was called large scale integrated circuit, VLSI. And examples are these many: IBM PC, Apple second, supercomputers, for example, Cray series computer. Now fifth generation computer, what we are using right now, these are portable. Like portable is what? And you can say your phone also, because few things, almost half of which you can do on computer, you can do now nowadays on your phone also, like MS Office documentation and other things, browsing of internet. And examples are IBM notebook, Pentium PCs, and Param 1000, the supercomputer that is built by India. Now we are moving ahead with computer generation based on software. Earlier computer generation we have discussed based on hardware. So now basically there are two programming languages, a group of two programming languages. One is low level and second is high level. The low level programming languages deal with computer hardware. Okay, and high level programming languages are used and software. There are two generations, first and second. And from third generation programming language, high level programming language. So now what is low level programming language? Deal with machine. So it is called machine level language. This type of language has only two symbols that is used to code this anything. Okay. So 0 and 1. For any instruction we have to give, see this cursor where I am moving. Give any instruction in this machine language, we have to give coding in this form 0101. Now what is this 0 and 1? So this is called binary language. Here 0 means off, 1 means on. So when electronic circuit is completed, means from one end to another electric current is passing, then it is called 1. When that circuit is broken, that means off. At that time computer reads 0. So this is called binary language and it is base of computer functioning. And this type of language was very difficult and only experts were able to work with this type of programming. So after that assembly language was introduced. Okay, and it is considered as second generation language. And in assembly language, instead of zeros and ones, now coding was done using these alphabets and words like sub, move, like that. Okay, so this was assembly language. Now we are moving to high level language. Now you can see this. This is one brick structure. Here programming languages are there. These are high level language. Okay, so at the bottom, what is their hardware? Okay, so first of all, computer come as blank, and to start working with it, we need to give instruction. So the first instruction that is given in computer is for hardware function. So that is done using machine language and assembly language. Then comes after that hardware, we have made hardware available to use by coding or instructions. At that time, high level. For example, high level language, the first one is your system software, that is Linux or Windows, Windows 7, 10, whatever you are using, that is coded in high level language. So that is the first software that you are using. Then for any application like for Paint that you are using web browser or MS Office, Word, PowerPoint, whatever you are using, these all are uh, prepared using high level language. Now this third, fourth and fifth, all these three generation languages are subset of English language. Okay. Now instead of zeros and one, we can use our own natural language, that is English, to code, to make any application or software. That is why it is called higher level language. So it is easy to learn and to work with. That is why that earlier limitations of assembly and machine language was removed using this higher level language. Now some example of higher level language are C, COBOL and Java programming. Now COBOL is not much used, but C and Java are still in market and they are popular. Now the fourth generation programming language reduce programming effort, okay, by just specifying what to do instead of how to do it. So you have to instruct computer what to do, not how to do that. That is, for example, SQL, that is structured query language. So this SQL language is used to create database type of application or software. Fifth generation language are designed to make the computer solve a given problem without the programmer. So sometimes when there is some problem, troubleshooting can be done automatically by software. That is called troubleshooting. So sometimes if your computer is not working, if you restart that computer, at that time some checks are done automatically by the system to make that correction when your system is unstable. Same way, there are some utilities. Softwares are available in your computer which help you to fine tune your computer. Now, examples of application that require such support is fault finding. Fault finding means where the fault is, why some application or system is unstable. Then voice recognition. When you speak, computer is doing some action. And intrusion detection. If some external source is making your system unstable or some software unstable, it is detecting that. Such carried out in transparent fashion from users in order to avoid complexity and to facilitate user-friendly interaction with the system. Now, whenever these things are done automatically, at that time it asks user permission also. If you give that permission, then only this type of tasks are being done by computer. Then AI technique, that is artificial intelligence techniques, can handle imprecision. Imprecision means when the output is not proper, or you are getting undesired output. That means output should be this one and some false results are being generated, and support human like self learning and problem solving. Now, types of software. Now, in high level language, we have discussed about system software and application software. System software is doing what part? It controls the internal computer operation, means how computer parts are interacting. For example, keyboard is where to send that input, and for processing, from where to get that instruction, and to where to send that output. All these things and other system maintenance or system functioning things are carried out by system software. So a system management program, that is operating system, device drivers, system utilities. Device driver is what? When you plug a new device into your computer, at that time it sometimes it does not start working automatically, but it shows you that install device drivers process. So that is drivers means software that are used to plug in any device and to make it work with your computer. That is device drivers. Then system software, developing software, that is programming language, language translator. What is language translator? So when you are using any programming language, high level programming language, at that time, as I said in previous slide, that you are using your natural language English. So computer cannot understand your natural language, that is words or sentences that you make for coding of any application or software. So there is one software that is called language translator, and this language translator translate your language into computer understandable language, because computer can understand only 0 1, that is on and off. So whatever code you are doing, that is translated by language translator into machine readable code. Then linker is there, which links files that are needed in your program, and loader that loads the file when it is asked. Okay. Application software, general purpose software, word processor that we are using, presentation, spreadsheet, and image editor. These are general purpose software. And specific purpose software, when any organization require this type of software, they have to make this type of software with some company. Then comes attendance system. These are again outsourced software, billing system, report card generator, etc. So these are not general purpose software which is meant to use by everyone. So these are specific purpose software, and these are general purpose software that is common for all. Now, types of software. Computer software can be considered as soul of computer, without which computer cannot do anything. Okay. So whatever task we want to perform, computer to do for us, we must have that software. In that software, that instructions are there. Software is organized collection of data and instruction given to computer in order to perform a given task. So in software, what is there? data and instructions. Okay, according to that instruction, computer is carrying out each task. The set of instruction is also called computer program. Now, the instruction that we are providing is called a program. Now, what is programming? When we are writing a program, it is called programming. And a programmer is one who perform this task of programming. Now, system software functionalities are booting. What is booting? When you turn on power to start your computer or laptop, and till you get that desktop screen on your computer, this whatever process are being done in background, that is called booting. Okay, when you are after booting only, your computer is ready to work for you, or you can start working with your computer. Then managing memory, that is system software manages this memory, that is primary and secondary memory. Channelizing data, from where to take data and where to send data, that is channelizing data from secondary memory to primary memory, because programs or and softwares are stored in secondary memory, that is your hard disk. So system software finds the necessary software coding from your hard disk, and then send it to primary memory for any task to be performed. Then managing printers. Okay, whatever printers are connected with your computer, after your command of print, that system software send required data to printers for printing, and other resources. There are so many other resources also. These are primary things we have discussed. System software is an operating system, that is example of system software. Same way for your mobile device. For your mobile device, what is system software? Android. And for Apple mobiles, that is iOS. Now translator we have discussed. Okay, translator program transfer your source code into machine readable code.